Hi, I'm Joshua Finn from J&H Aerospace. This is the build video for the Sweepette 28 and Sweepette 30 free flight discus launched glider kits from J&H Aerospace. And this airplane here is not actually that airplane. What we're doing is we're actually building out the first one of these that's actually a production version here, and it uses common mechanisms that are used on this same airplane. So as you can see, as we've demonstrated on video, it does have the so-called broken back dethermalizer system that is common on all current competitive free flight outdoor discus launch gliders. But anyway, the actual airplane that you're going to be building here is the published Sweepette 28, Sweepette 30 available online. We have our own set of plans that's going to be available. It's not completely finished at the time of this recording, but the aircraft is produced with Lee's approval after communication with him to make sure that the airplane meets the exact specifications that Lee had. As far as the outlines, mechanisms, etc., the airplane is pretty much in common with what is published online, with modifications to meet the particular timers and whatnot that we use on our airplanes, because I don't have the setup to do the exact same timers that Stan was using. So the published plans were set up to use those because Lee and Stan fly together very often. So this kit, like I said, can be built either as the Sweepette 28 or as the Sweepette 30. The Sweepette 30 is I guess you'd call it a compact outdoor discus launch free flight glider, as opposed to the larger 36-inch versions. The Sweepette 28, for our purposes here, is legal for AMA indoor hand launch. It's usable for outdoor, and it's a very fine airplane for that, but it's specifically, we're producing it so that you can use it for the 100 square inch limited AMA indoor hand launch glider rules for higher ceilings, like the U.S. Indoor Nationals at Round Valley Dome for as many years as it's going to continue to be held there. So with that discussion, and with the fact that this is an authentic Sweepette, it's not my design, it is Lee Hines' design with minor modifications to accommodate the mechanisms we use. Let's get started with looking at the kit to make sure you have all of your parts in your kit that you need to complete it, and then we'll build out the airplane. So your kit is larger than a typical J&H Aerospace balsa kit, because you have a 30+ inch long wing blank. Wing blanks are not tapered, at least as of this recording, and not for the foreseeable future will that change, because we don't have the machinery to do that. So instead, the wing plank is straight, continuous thickness. You have the marks here for your dihedral cuts, and for the center line, if you're building it as the Sweepette 30, if you're building as the Sweepette 28, you're going to cut the center panel out of here. You are going to have 3 basswood strips in your kit. You need to be mindful of those. So 2 of those are going to be 1/16 square, and another is 1/32 square. So these are going to be used for your leading edges for your wing, and this is going to be, this thinner 1/32 square is going to be used as the leading edges for your tail surfaces. You'll have a tail boom. Not much to say to that. It's just a standard tapered carbon fiber tail boom that is sized for the fuselage. Have your documentation packet. This isn't even the production documentation packet, so we'll just shove it out of the way for now. And we'll have some smaller parts here. And of course, use your bags and whatnot to keep track of all of these. So you'll have 2 plywood fuselage sides Be mindful these are different from each other, and look in your kit and make sure that they are different. One will have your timer cut out and one will not. And you have the little holes for your eyelets that go in here, and then the holes for your fuselage pivot, tailboom pivot. Matching those should be a 1/4 inch balsa fuselage core section with cutout for timer, ballast compartment, the little holes again, and then this cutout for your tailboom and a little slot for your incident screw. You should have a stab and a rudder, 1/16 balsa for those, piece of lead for ballast. This rubber is for your dethermalizer timer and for actuating the tail pivot. It's 1/16 inch rubber. We'll set that aside. Those of you that are wanting to fly seriously competitively will substitute this with a 10,000th or 8,000th piano wire spring that you'll use for tensioning. I have some fiberglass cloth for dihedral gauges or dihedral joints, and the reason for that is we're using this instead of the plywood braces that the Sweepette was originally produced with. Inside here, again, be mindful of all the little parts that you've got in here. So this is Kevlar thread. What you'll actually receive in your kit is spider wire. Just because when I put all this together, I was out of spider wire, so I threw that in there just as a placeholder. This guy, the trapezoidal piece, the long one, this is one of your dihedral gauges, and then you'll have two more smaller ones that are also trapezoidal. They don't look like it at first. So this is your outer, your tip dihedral, and then these are for your inner panel dihedral. And then for the Sweepette 28, you'll actually just glue these together to have one dihedral gauge for the center panel, because you won't have the 5-panel set up. This little rectangular piece is your wash-in wedge. This funky looking trapezoidal piece is the dihedral gauge for your stab. You'll have in here the cutout for your timer, and the reason for that is our timers on these are fairly small, so you can cut this so that you can set the depth you want the timer to be in there. Speaking of the timer, there is the timer. Sets in that cutout. You'll have this basswood piece with a hole in it. This is your pivot mount for your tailboom. You'll have these two little U-shaped pieces right there. Those are the eyelets for your dethermalizer line. I'm going to now start loading some of this stuff back in here so it doesn't get lost. You'll have a nut and a bolt here. Eventually these will be replaced probably by nylon, but this is for your pivot. You'll have this funky weird looking hook. That's the pivot hook for your tailboom. And then you'll have another somewhat more normal looking hook right here. This is the hook that goes up through your wing. And then this piece of 1/64 ply with a little cutout in it is a shield for your wing trailing edge. You'll have a basically a self-tapping screw here, and that's for your incidence adjustment on your fuselage. So keep all of those parts stowed away so you don't lose them. If you have built a J&H Aerospace balsa glider before, this step is going to be familiar. It's just there's going to be more of it. So the two 1/16 square basswood pieces, you're going to go ahead and wet those, and if you want to, you can go ahead and wet the 1/32 square one as well. The difference in this airplane is not only are we going to line the leading edges of the wing, we're also going to line the leading edge of the rudder and of the horizontal stab. So I'm going to come back once these are wetted out, and we're going to glue them to wrap them around the various edges of these parts so that they have better ding resistance and don't get chewed up by hard landings, by hitting stubble, etc. Okay, so what we'll do now is we'll go ahead and start with one of these basswood strips. These are not long enough to go across the entire wing. As you can see, I can't get them in sizes that are long enough, so what you're going to want to do is start this guy and just at the center and work it on around. What I recommend doing, once you get the glue flowing here, is glue this flush with an edge of the wing, and then that will accommodate your upsweep fairly well. Basically, it'll get you the correct, it'll set you up to get the correct cross section. I'm going to glue this all the way around here. So we'll start that roughly at the center, close to the center as you can, the center line as you can get it. It just makes getting that center dihedral cut. Actually, I'm not going to cut it at the center either way, so never mind. But it just is a convenient place to put it. And what I'm going to do is I'm going to wrap this around fairly far. And the reason for that is I want to maximize the protection that I'm providing to the wing. So about there is good. You're probably going to end up fiberglassing both wing tips, so it's not as big of a deal. It's actually more important on your stab and rudder than it is on your wing tips. And the reason for that is, like I said, you're going to probably fiberglass quite possibly both wing tips so as to provide your proper lateral balance to the airplane. My personal experience with these airplanes is that if you don't provide proper lateral balance, they swing toward the heavier wingtip as the airplane decelerates on the way up, and almost invariably that's the wingtip that you threw with, and you're wanting the airplane to swing the other way. So there's a strong tendency, if you don't provide proper lateral balance, for the airplane to straighten out and fail to transition correctly. And usually it'll recover in time to avoid a crash, but it doesn't change the fact that it will ruin your flight. Alright, so we've got the leading edge aligned for the wing. Now we'll proceed on, we'll do the same thing with the stab. I'm going to line it basically the same way. Stab does not take a huge amount of abuse, but it does take some. And what I'm doing is aligning the strip with the with one edge again. I'll show that up close just to avoid any confusion here in just a minute. Okay, so I don't know if it shows up real well, but I have set this up to where the bottom of this, to where the one edge of this strip is flush with this side. So then this becomes my top. Same thing, you can see I have flushed this, I'm now flushed with this edge, so this is the bottom of the wing. And so I'll carve into this to get my required upsweep. Alright, last step is we're going to do the rudder, and I recommend just putting that strip down the middle. You can put it to one side if you want to airfoil it. And you're going to want to wrap this all the way around, partway into the back side of your, it's not a rudder, it's a fin. But anyway, you want to wrap it all the way around. And the purpose of that is so if you land not under dethermalizer on a hard surface, the fin has adequate protection to keep it from getting chewed up, because these do get chewed up very badly if you land on a bad surface. And since the vertical stab is extremely influential in your flight trim, you want to watch that very, very closely. So all the surfaces are lined. There is something of an art to properly shaping a really nice hand-launched glider wing. And ordinarily I wouldn't have a huge discussion about that, but the fact is that you're paying fairly good money for this airplane. So as a result, you want to ponder exactly how you're going to do that. Now, we'll have some links down below, more than likely. If not, DiscusKid.net is an excellent resource for looking up the latest and greatest. Also, AMAglider.com all have discussions on the latest thoughts on airfoils for this airplane. You can look up the plans at DiscusKid.net for this exact pair of designs that share all of this together. But the bottom line is the stand foil is a thing, and you need to get the most out of your airplane, you need to pick which version of the stand foil you're going to use and accurately approximate it. This is a very nice razor plane, made specifically for me by Bruce Kimball, who actually drew the original published plans for the Sweepette 28 and Sweepette 30. I highly recommend not just using some run-of-the-mill razor plane. If you have to, however, the Stanley Mini planes, which are actually one of the cheaper options out there, are a very, very good option for this particular task. And if you hone them correctly and get the blades nice and sharp, they will give you, honestly, a world-class airframe. So if you're willing to put in the energy, they will give you performance actually as good as you can get out of this little guy. The Kimball planes, if you decide you're really serious about this and you want one, contact me through our website and I can get you in contact with Bruce, get you on the waiting list and whatnot. Bruce does not make these full-time, he makes them in batches, and so you can get on the list and get one. Regardless, the bottom line is make sure you have an appropriate tool for airfoiling this wing. Just a block of sandpaper is not it. You need to have the appropriate tooling for the task at hand, and that means some sort of razor plane, so that you can get your money's worth out of what is a hand-selected plank of wood for this particular airplane. So let's look at that plank of wood. What we're going to do, if you wanted to draw a line to establish airfoils and whatnot, you can. I personally do not. What I do is I kind of figure, about 25% back from the wing leading edge at the root is where my high point is going to be there, and what I'm going to do is wedge the entire wing back from there. And on a Sweepette style plan form, that's actually one of the reasons I prefer the Sweepette plan form. I don't have to curve anything around. I can just get that same taper all the way across, and then I will use my leading edge shaping to as far as to proportionately taper it down out here, and that automatically gives me the taper for my airfoil thickness. So what we'll do is we're just going to start planing the aft section of the wing. And so I'm inclining my plane at an angle here. I'm going and I'm cutting those nice beautiful curls. If you'll notice, I'm positioning this diagonally as well as tilting it so as to get the smoothest possible cutting action. And once you are into about this third cut here, if you've gotten the angle right, you can now just follow the angle from the previous cuts, except I slipped out right there. Have to be careful to prevent those curls from coming up underneath and stopping your cut. That one went into another dimension. Did it again. I missed part of the trailing edge right here because it came in too far. So we'll clean that up. And now we'll come at this again. So what I'm now doing is moving in here to try to keep this consistent all the way across. Because as this cut path widens, we want to keep it all as consistent as possible. What we're wanting to do, and as you can see, we've managed to get this much thinner than it used to be compared to the leading edge. We're almost halfway there. We want to get this down to about 1/32 of an inch thick at the trailing edge. You don't want it any thinner than that. 1/32 is plenty thin. So basically, we're just going to keep doing that, this process here until we get to that, and kind of evaluate how far this cut line is creeping forward, so you can make sure that you get that this correct spacing so that it stops right here when you're to the right thickness. So you may have to shift where some of your cuts are as you're doing this. getting closer. I think I may have gotten it right from the outset on this one. Except for that part right there. Wonderfully close, and we're the same thickness all the way along. That's something else you'll want to monitor as you do this. Almost there. That catch up here in a second. Looks like one more pass and we're done on the trailing edge. Definitely don't want to go any thinner. A little bit of a gouge there, but we can clean that up with sandpaper. And that looks a little pockety in there. Here we go. That is the back half of the wing done as far as everything except the finish sanding. Look, I don't know if it shows up real well, but there's just a nice wedge shape here. A few rough spots here and there. Those can easily be sanded. Okay, so after that, we're up about the 25% chord point here. And so what you're going to do is you're going to progressively straighten out back and forth across here. There's a flap that you want to cross the very front of the wing, depending on which version of the stand foil. There's some that are actually fairly rounded. not cutting correctly on this one, so it's not the right thickness all the way across here. Not the consistent thickness, whatever. Again, I want to mention, as you dig farther into this, you really need to look at which airfoil you're trying to imitate, and pick it and stick with it. And kind of think out what process you're going to use to achieve it. One of the things you'll notice is I'm having a little more trouble on this right panel, and that's because the grain kind of slopes in this way, and so it's ever so slightly kicking the blade out. It's enough to be quite frustrating. Section across here that's not down to the same thickness as the other side. Almost there. That's not going to work. Alright, so we've carved into that a little bit here. Bottom line is we want to turn the wing over now and work on carving in some upsweep. You can stop right about there. That was weird. Seem to have gotten a piece of basswood that's not completely straight in its grain either, so I'm going to have to go back and patch that. This is one of the problems you deal with on something like this. There we go. So we've got enough upsweep in there, so now I just have to go back and patch the part that completely, for no reason, just decided to tear out on me. try and clean some of that up. From here on, it's a sandpaper job. Bottom line is, got a few chewed up points there on the leading edge stripping. That's not too big of a deal. We've got a nice consistent airfoil across here. I don't know how well that shows up, but it's a pretty one. Okay, so off camera I did kind of flatten out the airfoil here to just, on our tips, to just kind of bare that all out. Like I said, with sandpaper, I'm going to sand the underside of this wing, and what we want to do is just kind of curve it on up. In the actual upsweep, you can actually ferret all the way back, about this far back on the wing, and that just continues to help the airplane fly that much better. Another thing to do is kind of fair your, or taper your leading edge strip so it kind of meanders into the profile of the wing. So once I'm done here, the airfoil should come almost, on the underside, should come up almost straight up like this, and then it's just going to be a wedge here at the leading edge, so it's actually a sharp edge that is curved up on the underside. Now, once you're to this stage, for this, you kind of want to go flat here, and then just kind of round it over at the high point of the wing. It does not have to be sharp at the top there. this thickness out here at the tips. The tips be nice and thin. So off camera, we sanded this this wing down, as far as finishing everything out. Got a really nice result here. I've got my up sweep and whatnot all the way around. I've got flat back here. I've got kind of flat and then curves over. So very much a stand foil type airfoil for our wing. And the result is nice. Got a few knot holes like right there that still persist. And let's get that smoothed out, and there we go. So at this point, what we'll do is we'll get some get the appropriate surfaces out here, and we'll start cutting our dihedral joints and whatnot. And we'll go ahead and establish, so if you're wanting to build the Sweepette 28, when you make this cut, you're just going to toss the center section out. If you're building the Sweepette 30, you're going to keep the center section. Everything else is exactly the same. And then for your dihedral gauges for the center section, those little ones, you're going to glue them together if you throw this center section out, so you can just jack one panel up all the way. On the other hand, if you are keeping the center section, then you'll hold it down while you just put one of the little dihedral gauges under this the outboard end of this semi-center panel. Same thing over here.
Hi, I'm Josh Finn. This is Hope. We are J&H Aerospace.
If you like this video, hit the like button.
Also, how about subscribe to our channel and check out jhaerospace.com for new free flight products and all of the tooling that you'll need to build them.
Thanks for watching.